So we have a conical paper cup that's 10 centimeters tall with a radius of 10. And the cup is being filled so that the water level rises at a rate of 2 centimeters per second. So they're giving us a derivative, and they're giving us the derivative of the water level. So if I call the height of the water line h, this is telling us that dH dt is 2. And then they want to know at what rate the water is being poured into the cup. So they want to find the rate at which the volume is changing. They want to find dV dt when the height of the water is 8. So when h is 8. So we need a formula for volume. Volume of a cone is 1/3 pi r squared h, 1/3 of the base times the height. And we'd like to get this all in one variable, all in r's or all in h's, so that we can differentiate more easily. So what we're going to do when we've got these cone guys is we end up getting these similar triangles here. This little triangle is similar to this big triangle. And so for similar triangles, we can set up proportions that the height of the water over the height of the real cone, the whole cone, is proportional to the radius of the water over the radius of the whole cone. And so this is an easy one to solve. It just is the height is actually the same as the radius. And so what we can do is I can substitute one in for the other. Now, I want to find dV dt, and they give me information about h, so I kind of like the h to live. So I'm going to put the h, substitute r for h, so that I've got h's in there. Cool. And so now if we just clean this up a little bit, I've got 1/3 pi h cubed. Now we're ready to take a derivative of both sides. Derivative of volume with respect to time is dV dt. And then this will be multiplied by 3. The pi is just a constant, so it's just 3 times 1/3 pi is just pi. Drop down the power, and then remember we're differentiating with respect to time, so you need to slap on that dH dt, the derivative of that variable itself, last step of chain rule. So now plug in what we know. We want to find dV dt when the height is 8, so just plug in the 8, and dH dt is 2, and so it looks like we're getting 128 pi. Slap on some units, centimeters, volume is centimeters cubed, and we are in seconds. So 128 pi centimeters cubed per second, check.